This take 5 is called active or passive presentation matters, but I'm warning you, it may be more like a take 8 or 10 or even a take 11, because I've got a fair bit to go through, so I'll rip straight into it. Now, I've been looking at my student feedback, and I've also had students comment to me in class, and one student comment that has really concerned me is that they say, I don't watch video streams. I don't watch video streams of lectures in courses, but I looked at one of yours just for the hell of it, just to see what was going on in the course, and I ended up watching the whole lot. And I said, well, why are you watching mine and not others? And the response has always been, well, yours are interesting and entertaining and active, and the other ones are often just someone talking about what is in the textbook. Hell. And I thought about this, and often I will talk about what's in the textbook, but I think it really boils down to whether you are active or passive. So today I'm going to give an active short lecture, very short indeed, followed by the same lecture done in a passive way instead. Today's topic is glaucoma. Now, glaucoma is a disease of the eye. It increases in incidence as we get older. It's very, very easily diagnosed, and if it's not diagnosed, you can go blind. Now, glaucoma is simply excessive pressure inside the eye. Too much pressure. I'll explain this. If you give your eye a prod, I'm looking at you, if you give your eye a prod, and I'm not recommending this, you're not supposed to do this, but if you give it a very gentle prod, your eye feels like it's a solid mass, a solid ball of tissue. Well, I guess as firm as a testis. Well, there you go. So I'm just giving my eye a gentle prod. It feels solid, but the interesting thing is our eyes are not solid. They are hollow balls. There's tissue around the outside, but they are filled with fluid inside. And the only reason why our eyes feel solid is that that fluid is under pressure. That maintains the rigidity of the eyeball, just like air inside a soccer ball keeps it pumped up. If you look at a person's eye from the front, the most immediately obvious thing is the pupil in the middle, which is just a hole which light gets to the inner part of the eye, surrounded by the iris, which is the coloured bit surrounding the pupil. This person has green eyes. Now, I'm going to get that person's eye, and I'm going to swing it that way. And I'm going to swing it around that way, so it's like a soccer ball, and then I'm going to slice it in half. If you do that, and you slice the eye in half, you will see something like this. No, you'll see, well, yeah, something like this. There's the pupil at the front. So looking at the same eye side on now, we've cut it in two. And behind it there is a convex lens, which sits suspended behind the pupil, and that gives an upside down view. Light gets in the front, and it gives an upside down view of the world on the photosensitive cells at the back of the eye. So at the moment you are seeing something like this. That's me on the back of your eyes. I'm in there. Now, oh, nice thought. So, the back of the eye is filled with jelly-like material. This bit's filled with rather jellified material. That's called the vitreous humour. Vitreous, a bit like glass. But the front of the eye is filled with watery material, which is called the aqueous humour. Watery. And that watery material, the same volume is secreted into the eye every day, and the same volume is removed, and that maintains the pressure in the eye. Now, that fluid leaves the eye, and it's a bit like air leaking out of a soccer ball. If you don't keep pumping up that soccer ball, then it's going to go flat. So every day more fluid is added, and that fluid slowly drains out of the eye, but more fluid is constantly added so the eye maintains its rigidity, and the pressure inside your eyes is usually between 12 to 21 millimetres of mercury. Don't worry about these bits, that's just an indication of pressure. That maintains the rigidity of the eyeball, keeps everything in place, and everything normally works just fine. But as we get older especially, one particular form of glaucoma can occur. I'm just going to enlarge the front section of the eye. I'm just going to make it huge. So there's the lens, same bit. I've just got this front bit and blown it right up. There's the lens, just got that and moved it over here. There's the iris with the pupil in the middle. Now, the fluid, this watery fluid, is secreted behind the pupil, secreted into the eye from our circulatory system, and the same volume is removed in front of the pupil. And it's removed by a network of very small openings, and these are called the canal of Schlemm. Schlemm was the physiologist who described it first. So as long as the addition of fluid to the eye balances the rate of removal, then the eye will sit at the appropriate pressure and everything is fine. But as we get older, there's quite a bit of debris in this fluid, little bits of cells, little fragments of cells, and as we get older, the canal of Schlemm often gets blocked up. The debris just blocks the canal of Schlemm and stops the fluid draining away very quickly, and therefore the pressure inside the eye increases. The canal of Schlemm, it's like a sink. When you've been washing up and you've got stuff in the washing up water from the meal, bits of carrot and stuff, then when you drain the water from the sink, that water starts rushing down the plug, and then these little chunks of debris get caught, and eventually you might even have a situation where the sink just sits like that. And what you have to do then, you're washing up, you stick your hand in and grab all this stuff and drag it out, and the fluid all drains away, blah, 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 and the sink's fine. But the canal of Schlemm, once it's blocked, and that will cause the pressure inside your eye to increase, and therefore once it gets above 21 millimetres of mercury, you have glaucoma. Glaucoma is bad because it presses on the light-sensitive cells at the back of the eye, it presses on the optic nerve, and it begins to damage those cells, and eventually it kills them, and you go blind. Glaucoma in about 7 minutes. And I've managed to inhale a nice amount of ethanol from the marker pens as well. Now, I want to do the same thing as a passive individual. So to aid my passivity, I'm going to go to PowerPoint. I'm not knocking PowerPoint as such, but boy, does it aid passivity. Ladies and gentlemen, today's topic, I'll get all serious too, like people seem to do when they're presenting PowerPoints. Today's topic is glaucoma. Here are the details of the human eye. You can see the coloured iris and the dark pupil in the centre. The pupil is just a hole where light gets inside the eye. Now, if you were to turn that person's head 90 degrees and cut the eye in half, so you'd have a cross-section of the eye, this is what you would see. So we have the eye seen from the side now. I'll just move my cursor so you can see it. There is the lens, there is the pupil at the front, pupil there in the middle, and there is the iris surrounding it. Importantly, what glaucoma is when the pressure in your eye is too great. Our eyes are solid things. If you give them a bit of a prod, then they feel very solid, but they're not solid, they're full of fluid. They're full of jelly-like material at the back of the eye, and they have watery fluid called the aqueous humour at the front of the eye. And that aqueous humour is under pressure between 12 to 21 millimetres of mercury, and that pressure is maintained by the constant secretion of fluid into the eye every hour or day, and the constant removal of fluid via a structure called Schlemm's canal. Normal pressure 12 to 21. Glaucoma is when the pressure is greater. Pressure is controlled by the secretion and absorption of the aqueous humour. As we get older, the drainage of the aqueous humour is often impeded, and when that happens, when Schlemm's canal becomes blocked by cellular debris, then pressure in the eye builds up, secretion continues, but absorption is blocked, and therefore pressure in the eye increases and you suffer from glaucoma. Pressure greater than 21 millimeters of mercury. This compresses the blood vessels supplying the retina, it reduces the supply of oxygen to the cells of the retina, it compresses the optic nerve, and it causes blindness. So, ladies and gentlemen, it's easy to get tested for glaucoma. It takes a few minutes at the optometrist only, it is painless, simple and straightforward, and it can actually prevent you going blind. So that's it for my passive demonstration. Now that almost killed me, being passive. You probably said, wow, it's really good with the PowerPoint, Steve. Made a lot more sense. But I want to finish by saying, okay, active and passive. What's the difference? Well, I use PowerPoint as an aid to being passive, but you can be passive without PowerPoint. The passive, no more than what's in the textbook. The active, I had simple, conceptual explanations. I tried to be lively. Well, writing on the board I think is pretty damn lively. I also moved a lot, but the other thing is I used some pretty straightforward but easy to remember analogies. The soccer ball constantly needing, or the car tyre constantly needing to be pumped up to maintain pressure when it's got a leak. Glaucoma, when the leak is blocked. Schlemm's canal is blocked. Schlemm's canal as a sink. Instead, compared to this, the passive presentation was a series of complex diagrams. Which in my mind, when I see these things, give me a sense of great overload. After a while, I just switch off and go to sleep. And it seems like my students would do that too if I gave them a passive presentation. Now, I'm not knocking PowerPoint, though people have knocked PowerPoint. You can give such beautiful looking presentations that you forget to be active and teach. You're just the talking head in the corner, supported by amazing coloured complexity of diagrams that the mind after a while just goes fuzzy and says, I can't take all this in. So I guess my take-home message is I think we should all strive to be active when we teach. It's easy to be active with PowerPoint. You can toggle back and forth between presentation modes quite easily. But I think we need more activity, more engagement, because activity fosters engagement when we are presenting our video streams. Thank you.